7 mysteries, 1 interstellar object, and a story that challenges everything we know about the universe. From the silent depths of space, a visitor arrived. 3IAtlas. In July 2025, the Atlas Research Telescope in Chile detected a strange, fast-moving light. It wasn't just another comet. It was something different, moving at over 130,000 miles per hour, escaping the pull of the sun forever. Scientists soon realized this was no ordinary traveler. It was an interstellar visitor, the third ever detected in human history. But this time something felt different. This object would not just visit our solar system, it would rewrite what we thought we knew about it. Its trajectory was hyperbolic, meaning it came from outside the solar system and would never return. Its speed was measured between 37 and 42 kilometers per second. No known comet moves that fast. The first images showed something elongated, not round, as if the object was slowly tumbling through space. Estimates of its size varied wildly. Hubble's data suggested a core no larger than 3.5 miles wide, while ground-based telescopes saw something perhaps as small as 1,000 feet. Whatever it was, it didn't behave like anything ever seen before. As it approached the sun, telescopes detected jets of gas erupting from its surface, a clear sign of outgassing, just like any comet. But there was one problem. The object didn't slow down. No measurable change in its orbit. No gravitational deviation. Nothing. Normally these gas jets act like tiny thrusters, nudging a comet's path slightly off course, but not this time. 3IAtlas moved like a stone, ignoring its own exhaust. To resist that force, it would have to be unbelievably massive. Some estimates put its weight at over 73 trillion pounds, making it one of the heaviest known comet-like bodies ever recorded. But there was more. Unlike any comet ever seen, 3IAtlas had no visible tail. Instead, it was surrounded by a vast green haze, a glowing envelope of ionized gas. Hubble's imagery showed a diffuse, spherical halo rather than a sharp stream of dust. It looked more like a living cloud than a comet. The green color hinted at gases like cyanogen and carbon monoxide, excited by sunlight. But the sheer scale of this halo defied explanation. The object seemed to resist the sun's radiation pressure entirely. It wasn't behaving like ice and dust. It was behaving like something else. As scientists studied how light scattered from 3IAtlas, a new mystery emerged. The light coming from the object showed a record-breaking negative polarization, minus 2.77% at a phase angle of just 6 degrees. In simple terms, the light was polarized in the opposite direction to what physics predicted. No known comet, asteroid, or trans-Neptunian object had ever shown this behavior. 3 independent telescopes, the VLT in Chile, the Nordic Optical Telescope, and FS2, all confirmed the same result. Simulations using every possible dust composition failed to match it. Nothing, not even the most exotic mixtures of carbon and ice, could explain the data. For the first time, comet scientists faced a reflection curve that simply didn't make sense. Then came September 2025, a month of intense solar activity. The sun released several massive coronal mass ejections, hurling charged plasma across the inner solar system. Historically, such storms have torn apart comets, stripped away tails, or shattered fragile nuclei. Yet 3IAtlas remained completely untouched. No increase in brightness, no structural change, no loss of material. Solar physicists reviewed data from the solar orbiter and ground observatories. They found no trace of impact, no measurable disturbance. The object simply ignored the sun's fury. For a visitor from deep space, its stability was unnatural. The question grew louder. What kind of body could shrug off the sun itself? During its closest approach to Mars, something unusual happened. For 11 days, NASA's public tracking feeds for 3IAtlas went dark. No updates, no observations, nothing. It was the very window when the comet was most visible, and yet, silence. Requests for data returned only maintenance messages. Some amateur astronomers claimed to spot a faint streak in a Mars rover camera feed, but NASA neither confirmed nor denied it. Speculation exploded online. Was the data blackout intentional? Were there classified radar observations hidden from the public? Officially, there was no comment. But for researchers, those 11 days became a black hole of information. Three main theories now compete to explain 3I/Atlas. The first, it's natural, a rare comet shaped by chaotic cosmic forces. The second, it's a planetary seed, a fragment of a world once part of another solar system. And the third, it might be artificial. Harvard astrophysicist Avi Loeb suggests the object's mass, polarization, and trajectory fit no natural model. He estimates up to a 40% chance it could be engineered. For now, no proof exists, only data and questions. After its closest approach to the Sun on October 30th, 2025, telescopes around the world will track it again. Hubble, James Webb, and ALMA are scheduled for follow-up imaging. ESA's Mars and Jupiter missions will monitor from space. Every observation could redefine what we know about interstellar matter. If even a few anomalies hold true, then 3I/Atlas isn't just a visitor. It's a message, a reminder that the universe may still hold builders, travelers, or watchers, and that we may not be as alone as we think.